This is Nitin Dahad with the Times. I'm speaking today to Stelios Diamantidis, who's a distinguished architect at Synopsys. Stelios, hello.
Hi, Nitin.
How are you?
I'm doing very well.
So last time we spoke was when we did a podcast, I think maybe 2 or 3 years ago, when you'd launched the AI in EDA efforts. But tell me, what have you been up to since then? And obviously, there's a lot of things happened in that time frame.
Absolutely. It's been an incredible year at Synopsys when it comes to artificial intelligence. We started our Center for Generative AI last year. We've had some of our great technologists and leaders in different aspects of operations and engineering and product come together to define how generative AI is going to help us drive the world of chip design forward. And we've really focused, Nitin, on 3 vectors. Vector number 1, of course, how do we serve our customer community? How do we create better solutions? Vector number 2, how do we internally use AI for engineering productivity? We have thousands of developers and chip designers right here at Synopsys that can leverage the solutions themselves. Vector number 3, our entire corporation, our entire enterprise, everything that we do from sales to marketing to finance to people can benefit from the solutions in generative AI.
Yeah, I mean, just for I mean, I haven't done a video interview with you before, but for our viewers, tell us a little bit about your background, because it is quite impressive as well.
Thank you, I appreciate that. So I have, in my view, one of the best jobs in the industry. So I run this Center for Generative AI that I mentioned about before. And what we try to do, and what I try to do in my everyday job is, really bring in technology, new solutions, and map them to problems that can benefit from generative AI, then activate really the entire company when it comes to deploying the solutions, designing new products, benefiting from it. So it's been a fantastic journey.
When I spoke to you last, I think you said you'd been working on this 5 years before. You'd been given the brief 5 years before you launched. So there's quite a lot of work behind it, isn't it?
There's a lot of work behind it. And I think what we did very, very well was get involved in AI early. Our program started as early as 2017, which really, AI was very different from AI today.
Yeah.
AI was very much about optimizing spaces, figuring out how to find global optima in areas that really cannot be searched through traditional algorithms. And then, of course, the world changed in 2022 with the introduction of ChatGPT, right?
Yes. And that 2022 to where we are now, 2024, end of 2024, really, by the time we're recording this. So it's changed exponentially because of ChatGPT, but for chip design, what does that mean? Because there's a lot that you can do that I've seen in Snug over the last 2 years in terms of using AI in EDA, but also the complexity has increased, so then there's a lot more to do.
You're absolutely right. And what you're actually able to do is actually been growing. And you mentioned the 5 years before. We try to be very aggressive with the things that we can do, but we also find this timelines being compressed, things that we thought, well, this is not going to happen for, let's say, 5 years. We find ourselves actually find paths to it sooner, and that is changing the roadmap constantly, right?
What has astonished you in the last 2 years in terms of the progress you've made or the progress in the industry, both? I mean, there's 2 vectors there.
Yeah. Actually, a number of things. First of all, I'm very, very impressed at the rate at which technology is being created, proliferated across the industry, and that would be both within our semiconductor industry and outside. The second is the incredible productivity and the incredible innovation in the silicon that has enabled the AI algorithms to run, right? The new chips, the new architectures that have been proposed and brought to silicon super quickly, the way that they've actually driven products into market. And then the third one, of course, would be the way that we've been able to actually deploy the solutions in the chip design space, and really within months being able to work with our closest partners to bring the solutions to their environments and validate them and even begin to see benefits. These are very, very fast timelines for our industry.
On the second one on that, I mean, can you give us a scale of the parameters involved in terms of, I don't know, gates or how much has gone into that complexity now, the chip complexity?
I think the scale complexity has been quite amazing, right? We've gone through...
Give us some scale,
idea
of the scale.
I think we've gone from hundreds to thousands to now millions potentially of processing elements that are mapped into these kinds of chips. then chips interconnects have grown tremendously to be able to support the scale. Memory standards have exploded, right? So whereas we used to see a sort of a growth in memory standards that would map from, let's say, 3 to 5 years, now we're seeing 18 months, new standard with significantly higher bandwidth, new topologies, all to bring data closer to computation. So all these architectural trends have actually been rethought. And think about what it means to actually put that in an actual socket. You have to solve all the problems around it, the physics of it. Clearly, anybody who works with our industry is worried about two terms right now: energy and heat, right? How do I consume less energy? How do I move heat? So all these other problems that are not maybe specific to AI, but as a result of all this dense computation, the huge parallelism, and the compute and memory coming closer together, these are other challenges we have to deal with. I've been
seeing a lot of compute in memory developments recently, so I guess that's going to be happening as well, and you probably are looking at that as well.
Well, there are the workhorse compute engines that we're seeing the scale up, and then we're seeing all kinds of other architectures being introduced for in-memory compute, for example, that are trying to take different kinds of computational workloads and create solutions that are more customized to those workloads.
By the time we're going to publish posting this, it'll be predictions time, 2025. What are some of your thoughts on what are the key things to watch out for?
Yeah, funny you should mention that. There's actually a blog that we're posting on this, which is really looking at where we've come, the timeline over the last, let's say, 12 months, where we predicted earlier we're going to see the rise of copilots, right? So copilots meaning assistive solutions that help engineers identify solutions faster, maybe do some collateral generation, and generally accelerate their everyday, right? That's where we really have been.
Is that, just on copilots, is that like prompt engineering? So basically you put prompts in and you get sort of blocks and designs, is that right?
It is certainly one aspect of it. So prompt engineering for chip design is a thing, and certainly it's a skill that we also see a lot of our customers developing. But then you bring other aspects to it as well. One is, of course, the ability to implement RAG. And RAG in the context of chip design, what is that, right? Yeah. Defining that has been a very interesting application. Looking at how data can help fine-tune models in an economical manner so that those models can become high productivity models.
Use the data, I think that's what I think.
Use the data.
You've got so much of it.
Indeed, you have to use the data. But going forward, we're seeing now the clear emergence of yet another trend. So, we've talked about AI being assistive, providing engineers with insights. We're seeing AI also being able to perform certain tasks fairly autonomously, which we refer to as agents. So agents for different domains that are expertly trained to do specific tasks are now being integrated into the solutions.
Give one or two examples.
So you can imagine of agents, in a very simple form. An agent can be a small independent piece of software that can actually perform a computation. It could be as simple as a numerical computation. Yes. It could be as complex as calculating aspects of a graph when it comes to power or timing. Okay. It can be something that can look into tool outputs and extract insights and then take action on the insights. Right. So all these kinds of different agents, you can have a great polymorphism, and in fact that's one of the predictions that we're going to see great polymorphism. But the nugget that I wanted to bring up with you, really as we see this as a prediction, is those agents now beginning to collaborate, and that's something called agents talking to agents, or AI to AI collaboration, as we like to refer to it. We're seeing the very early days here.
Agent to agent rather than
you
AI
like
to
agent?
AI.
It's very true, and it's certainly more technically accurate.
Yeah.
But it is something that is really at infancy. However, we really see this sort of timeline of these things happening, not in 5 years, but maybe in the next 18 to 24 months.
Is this appetite from customers, or is this something you've been working on, thinking this is going to help customers, so we need to develop it?
Yeah, it's the evolution of the overall approach. It's a natural path. That's when you start going down the path, then the next steps become visible, and then when you need to break down the next barrier. Those are the ways that you're
Are you into science fiction? What do you envision as a result of this in the future?
I think that we're seeing some very practical steps. So while I'm a big science fiction fan, really what we're seeing right now are very practical, pragmatic things, and also economical things, meaning things that are not going to break the bank, so to speak. So I think we're going to get some really great productivity solutions and a steady stream of them as we go forward.
Okay. Well, what do you want our viewers to sort of end on? What's the key message you want to give out there in terms of the generative AI, in terms of the work you're doing?
Well, I think that it's really a fantastic time, what we're going through, the kinds of technologies that are coming together to solve problems, really across the board, right? We have solved problems in enterprise productivity that are amazing, right? For example, we are able to consume reports and consume information in finance to help finance teams perform more efficiently, right? But in the expanded scope of an enterprise, I think it's unique that we're seeing technology intercept really the entirety of a company's operations all at once, right? Maybe we've seen the internet have a similar effect in the past. What we're seeing now really, I think, is something very, very important from the point of view of the global scope of application. And I think that's also very unique in the way that we treat it here at Synopsys, that we created the Center for Generative AI to capture all these problems and to create technology solutions that can map to all these problems.
Okay. Well, good. Well, Stelios, thank you very much.
Thank you very much, Nathan. Great talking to you.